students and enthusiasts. Welcome back to my channel once again. So again, I've come up with one more project that is a little unique type of project. So that is Dual-MCU, environmental monitor with local display and web dashboard. So as the name suggests, Dual-MCU. We have used two microcontroller units here, and we have also used two different language also. That is one program, one MCU is programmed with an C++ and another one with MicroPython. So let's go and see what is there inside and what we can learn. So well, the objective is I have built a genuinely different project than the usual single board tutorial. That is usually we only single board microcontroller board or embedded system board we were using it. A two board wireless environment. Okay, two board we have used. Monitor where the Pico W, that is one board is Pico W, does the local sensing. That means all the sensors are connected to it. That is OLED display and other sensors. And the ESP32C3, that is super mini board, very small board, act as a Wi-Fi gateway serving as live web dashboard. Okay, so C3, that is ESP32, we have used C3, smaller board, for live web dashboard. They talk to each other over Wi-Fi, which turns it into a live web page. That is ESP32 will generate a live web page. Anyone on your network can open this UART. That is, if they have the IP number, then you can open it. All right, so this program or this project also can be done with the UART handoff pattern also, that is directly connecting each other. Okay, the TX and RX, we can directly connect both the MCUs. So here, but we have used Wi-Fi. But in our project, the communication is wireless and read also as a dashboard. That is, there is a available dashboard also in this. All right, so let's go to the second part. That is, what are the components we have used? So I have used Raspberry Pi Pico Zero. That is a Pico board, not Zero actually. I have used Pico board. Okay, one. ESP32C3 Super Mini, that is one, that is with the Wi-Fi. Both of them have Wi-Fi. Please remember that the Pico W is also having Wi-Fi, and this is also having Wi-Fi. I have used a DST11 sensor for temperature and humidity. Right? Instead of, you can use DST22 also. LDR I have used with 10 kilo ohm resistor. That is single LDR I have used for your light intensity. Soil moisture sensor I have used, that is alert, but in my case, I have used another sensor, that is, we call it a rain sensor. It's just like your soil sensor, but the only difference is the intensity of water falling on this sensor. It will read that. Okay, so we can change the name to rain sensor also, or sensing the rainfall measurement also. We can put it like that also. Anyhow, SSD 1306 I have used, that is working on I2C already, and few jumper wire and breadboard. These are the simple setup for this thing. All right, so circuit connections are as shown here. I have drawn a small circuit also, but I will show you it later. Very rough circuit. So DST22 or 11 is connected to GPIO 15, which works on 3.3 volts supply, right? And LDR voltage divider, that is connected through divider. It is connected to GP26. That means the LDR one end is connected to supply, another end is connected to ground, and from center we are given it to GP26. That is a ADC connection. And soil moisture analog output is given to GPIO 27. That is also ADC. OLED connection to SDA and SCL are given to GPIO 4 and 5 respectively. And this also works on 3.3 volts. So mostly all the three sensors are, the supply voltage is 3.3 volt, which we have taken from Pico W board itself. So as it has been shown in this. Okay, so this is just a small this thing, that is display, local display, and MCU, it is connected to local display, as well as you can check it on this thing also, like web dashboard also. So system architecture, how it is working. So what things is to be remembered. First, you have to flash the ESP32C3 first with ESP32 gateway. That is, we call it as a gateway Wi-Fi system. Serial monitor, first after loading it, you have to check the serial monitor and note the IP. That is some IP address region. The example we have given, some example is there. You have to copy that out. Okay, copy that IP address. Now you go to the Pico W sensor node Wi-Fi P1, that is in Python. We have done it in Python, that is using Thorny ID. Fill in your Wi-Fi credential there. That is your IP pin, what you got it from ESP32. Save it as a main PY. Okay? Few more changes is that you have to do it there. That is SSID and password. In both the cases, you have to give. Okay. It reads sensor shows them on the OLED. That is, all the data will be shown on the LED with the small Wi-Fi status indicator. Now the post JSON HTTP script, we can say update every 3 seconds. Okay. So these are the things what you have to keep it in mind. And simple schematic diagram, rough schematic diagram I have drawn it with my hand. So this is the schematic diagram. And let's go and see both. We will be sharing the codes also. I'll explain the code, both the codes. That is ESP code in Arduino as well as Pico codes which are in MicroPython. Communication is Wi-Fi. Okay. So Pico, we call it as a node Wi-Fi, and ESP32, we call it as a gateway. So let's go to our lab and check out the real project, how it is working. Lab, I will just give you the complete idea about the setup. As you can see, 3 things are going on here. So one is my mobile application, which is connected to my ESP32C3. This is the small board, please remember. The board which is given in the back, this is ESP32C3. No other connection. If you want that, this has to be little long distance, or it has to connect with the other microcontroller MCU, then you have to add one antenna, okay? Because the antenna issue is there in this also. So you have to be very careful with this. Here, you have to connect an extra antenna. All right. So this is my ESP32, that is my gateway Wi-Fi. Gateway Wi-Fi is giving this signal, which is also coming on my Pico node Wi-Fi. This is my node Wi-Fi. This board is node Wi-Fi. So what is connected to node Wi-Fi? I will just give you first idea about it. So I will just give you an idea about what is node Wi-Fi. So this is a DST11 sensor which is connected. I have connected rain sensor actually, but you can connect anything. Right, I will just show you what is the changes taking place. Now it is 73. I put little water on it. So let us showing 71, 72 and all. It will take little time over here to update moisture level. It will take little time. Now it has come. You can see here. All right. So moisture level, soil moisture level, rain intensity. All right. This is my module, and you are having a light sensor also. This is my light sensor, the LDR. I will put my hand on it and show you what happens. So it has gone down. You can see what are the changes. So it has come up. Okay, 29.6 it is showing. 18 now it is showing. But here it has not changed, but it will take little time. Okay, now it is 29 because 3 seconds is the delay time we have given. Now it has come to 18.6. Humidity and temperature same, what you can see it here. So this is the web dashboard, which is connected to ESP32, which is working on. We have programmed it with Arduino IDE, that is C++ programming. Okay, so these 2 things from here, it is going to this place. Okay, now this board I have programmed it with my MicroPython. Okay, this is my Pico W board. Pico W board. It is connected to, as I said, this is connected to your DST sensor, that is a temperature, humidity, soil moisture, and light. Okay, that's why we call it as an environmental monitoring. All these parameters are coming over here. As you can see, all the parameters will be coming over here. All right. So like there's a small loose contact over here. So we'll see. Okay, temperature has come now. Temperature is coming. It will take a little time over here. So Pico W with MicroPython. LDR is connected. One end is connected to 3.3 volts. All the sensor. This is also connected. This is also connected to 3.3 volts. Please remember. Okay. And all the data pins. The data of this, that is this wire is coming to GPIO 15, and rest of you can see the 5, 4, and 5 for my OLED display. And for sensor, that is analog, and this sensor, it is going to analog pins of my this, that is my microcontroller. Okay, so these 2 points, everything is working on this on 3.3 volts only. So 3.3 volts, I've taken it from here only. That is the pin number 1, 2, 3, 4, 5. Fifth pin is 3.3 volt output. This is ground. Even this is ground, okay, for the resistor. So you can see here how the things are working out. Okay, if you have any further questions or this thing, you can do write to me. I will share the codes also, both the codes. That is, I will share my C++ code as well as MicroPython code, so that you will get idea. The idea is only getting something new. That is, one microcontroller is working. This microcontroller is working with what? Suppose this microcontroller. This is you're working with MicroPython, and this microcontroller. That is, this microcontroller is working with C++. That is with Arduino IDE, and you are getting the complete details on your mobile screen, that is light, soil moisture, all the details you will be getting over here. Okay, right now it is showing 0. Why? Because there is no water on this, so it is showing 0. Okay, the light intensity is this thing. You can make it dark and you can make it how it is changing. It will be in every 3 seconds it will be getting it. So that is the idea. That is how you will make all these projects, and how to use two sensors, how you will make the project and how you will use two sensors. That is the idea of this thing. I hope you will like it, and if you liked it, please do comment to us. Okay, now we'll go to the code part so that you will understand the codes also. We see ESP32 development board, that is the development module here. That is, it is in our Arduino IDE. Okay, so these are the programs. I will just show you. The program starts from here. So these are the 4 libraries. You have to SSID password you have to give. DXRX you have to indicate if you are giving it a UART connection. Okay, 2021 is the UART connection we have given over here. So all these things. This is HTML dashboard and how it will be coming. Like we have already seen the HTML dashboard, how it is coming in here. So that is our HTML dashboard. All right. So you will get a Wi-Fi connection, and you have IP address also over here. But main thing why we have done is this Wi-Fi for just getting this IP address. So you can see all the light and intensity, it is already coming, and this is the IP address. This is, you have to copy this IP address, then you have to take it to the next level. That is the reason first you have to program your ESP32C3 in Arduino IDE, okay, in C purposes program. So these are the complete codes of which I will be sharing with you. And very simple, what you have to do is you can use ESP, any of the ESP. I've used a small ESP, as you can see in the picture here. I have used small ESP over here, but you can use any of the ESP. Okay, the bigger size and the other, this thing also you have to know. Only the password and forgetting this IP address. So this is a part 1. And now what I will do is I will tell you about the second part. Okay, we'll go to the second part. That is the programming of the Pico and with Tony. We are into Tony ID, that is for MicroPython. So this is the program for that. All the connections where you have to give what you have libraries you have to use. So first 4, these are the first 4. Sorry, 1, 2, 3, 4, 5, 6. These are the libraries you want should have. Now, please remember SSID 1306 compulsory separately. You have to put it here. You can see this is SSID 1306. You will get it on the web also, or it will be there with you also. That is for the display part. Okay, and the main PY, that is the main library, that is we have to give SSID and password. The same what we have given in, we have copied from ESP32S3, we have copied it here. That is the IP address which was there, we have copied it here. Pin configuration, DST11 I have used here. You can use DST22 also, it will automatically sense it, and rest of the SCL, SDA and other pins, analog pins have been given over here. So how it will be done, how it will be transferred, that is also given in here. That is sensor readings, how it will be there, that is 2 over Wi-Fi, that is important. That is how it will be transferred from here to my ESP. Okay, so that main loop and everything is I'll be sharing both the codes with you, and it will be coming onto your these things. So what are the main important things? You have to remember SSID password and this part, that is your IP which you have collected or you have taken it from your ESP program, that is C++ using Arduino IDE. Okay, so that you have to copy and you have to paste it here. Rest of the things are very, very simple. Okay, and after doing all these things, then only you will get this output. All right, and you will get this thing also. Please remember, when you connect it, when you program it, give all the connection first, then only it will come. That means all the readings will come. If you if you are not connecting it and you are program it, you will get, definitely you will get error. So that one part you have to be very careful about. Please give the connection, then only you will have this thing. Okay, then the communication takes place. If you don't connect display now, it will never come. Okay, I hope you like this project. If you like it, please share with your friends. And please, I have many projects related things on electronics and electrical on my channel. So please subscribe to my channel. Thanks for watching. See you next time.